Here what data is generated. So from here it will be FTP, like it will be transferred to your cluster Linux. It will be there in your node landing directory, and inside there will be this will be HDFS. So this is how it's. Data will be here. From here, daily we will be transporting it to HDFS.
So what's the black one?
This is some other outside server, web server, wherever it is getting generated. Backend of some website server, like .com or something.
So you get through the what do you call the web IP addresses.
Yeah. So from here we can use SFTP. It's just FTP only. FTP we can use, or any other file transfer protocol we can use to push the data to our Linux.
So the black box will be a Linux server, right?
Correct. Black box is a Linux server.
The one I sent you in a text message. I'm trying to understand that command. Hadoop FS dash put source file underscore path / user xxx lab. So what is that?
Hadoop FS is file system. That is the syntax.
Okay.
-put is also a syntax that is saying you are going to push the data from source to target.
So source to target, which is source now? Is it in
So no, this command you will not be able to use it here. Okay. This source is your Linux path.
Okay.
Linux path. This is your Hadoop path.
Okay.
Like, for example, I'm opening here. Let's say I have a file called input.txt, right? This is there in Linux. If I want to push this into Hadoop, I will use Hadoop fs -put. Source is what? Input.txt, right? And then target is HDFS. I'm using. Got it?
Okay. So the other way around, get also so something similar?
Yeah, you can use get from. Get is getting the data from HDFS to local. So there you have to give the sources HDFS path. Get.
So this up to Cloudera you put / right? That's a root path, right? For Cloudera root.
Your user path, like which user you logged in, that user path.
Okay. So now the file is under the Cloudera, CD Cloudera. So you will see the input.
You will not be able to do CD in Hadoop because it is a virtual file system. You have to type always the entire path.
Okay.
There is no CD in HDFS.
Okay.
Because it's a virtual file system, you have to put the full path always. Like this.
Okay.
If you see, it is there. Input.txt is there. It is copied third, like 630. Got it?
Yeah. Got it. Thank you.
Okay. Okay, so let's start the class. We are already late, but somebody is not yet joined. But anyway, we'll start it. So yesterday we have seen the MapReduce program. Can all go into mute, please? Anandji and Shankarji, can you be in mute? Shankarji, can you please be in mute? Okay, thank you. So yesterday we have seen MapReduce. how it, what are the basic things and how it works. Basic we started seeing, and today we will just try to execute a program and we'll see how the map and reduce is getting actually implemented and what is the power, like how we can optimize it. Those things today we'll see. Okay, before that, I'll just show you the blog. This blog is very good for map reduce perspective. This is from Yahoo, and it has clearly structured what are the each steps and all. Everything is very clearly structured. So this blog is very useful. You can go through this blog. Okay, hi Ganesh, good morning. So this you can go through, and here I'll just go to one diagram first. Okay, so these all the things are, each thing it is just whatever we yesterday seen only, that is only there. So that is a program, that's program. This is also fine. This we do not worry. Okay. So here I'll just save it in our drive. Okay. So if you see the structure, so first the file is there inside there, and then what happens is, first thing what happens is the split. After the split, there is a record reader that will read the data. Once a record reader reads the data, from there the map function will happen. After that, there is something is running which is called partitioner. So partitioner is used for shuffling purpose. Okay, that we will see it. After that, there will be sorting will happen, and then reduce function, and then output. So these are the different technical steps that is happening in behind the map reduce program. Okay, so in these steps, what are the things we have to specify? So what are the things we need to write in our program? What are the things we have in our control? For that, we will just start have a look into one simple program. Okay, so that I have it in our assignment batch. I'll just go into our batch. Then
Before Arumugam, can you please just go to the slide, last day's slide on the split and everything, the split one. Can you just go over it?
This one?
Yeah, this one. Okay, can you please explain it so that I can brush it up?
Okay, so there are only very few steps in this entire process. First is the data is there in a SDFS. After that, first the splitting will happen. Once the splitting is happened, then map will execute on top of the each data chunks, each splits. Once a map is completed, after that the particular keys and values will go into particular reducers for processing the values. So once that is called shuffling. Once the shuffling is completed, after that the reducing process will happen on top of the data chunks. Once the reducing is completed, then the entire final result will be shown, will be written into SGFS part. So this is the overall flow of map reduce. First split, after that mapping will happen. After mapping, there will be something called partitioner. The partitioner will send particular keys to particular reducer, so that all the keys will go into only one reducer, so that it can be processed easily. After that, the reducing will happen. After that, final results.
Split will happen against one particular block, or it is
so mapping will happen on a particular block. Correct.
No, splitting.
Yeah, that will happen on one particular block only.
Okay.
Okay. So here we have to specify three things. When we are writing a program, like whatever we are going to see, we are going to write the map reduce program in very, very detailed level. We will be specifying the mapping, what is mapping, what is reducer, and everything we will be specifying in a very granular level, and we are going to write the program in the native language. So native language for Hadoop is Java, because Hadoop is written in itself Java only. So we write the program in native language, but we will not use this more in production scenarios. No, we will not use it. Why? Because it takes more time to write a program in Java. That is why we developed a lot of tools called Hive, Pig, and those things we developed just because of this only. This will take a lot of time, and we need to write each and everything in coding level. We need to specify what is the mapping, what is the input format for mapping, what is the output format and all. It will take a lot of time. Okay, so this flow is fine, right? Any doubts with this flow? This is the overall flow. First input split, mapping, and then partitioner will send the particular keys to particular blocks, which is reducer. That is called shuffling. After that, reducing will happen on top of the values, whichever is partitioned.
Where the record reader is coming into, so after input,
it is there in a splitting itself. In this part itself, record reader will take it.
Okay.
So I'm just going in there, and then we have a folder called Java MapReduce, and in there we have a program, like we can delete whatever is unnecessary. Okay, word count Java, we'll just open it here. So this is a very basic Java program. So how many of us know Java basic syntax at least to understand? Anyone doesn't know about Java basics at all?
Very few.
I don't know.
Long time back.
Okay. Okay, then okay, yeah, even that should be fine. Anyway, that should be fine. But what we are going to see is just a like program level implementation of the MapReduce. So if you see the syntax is a little bit of, you might not know the syntax of Java because nobody, it is very difficult and it is new only. So you don't have to worry about the syntactical, how it's done. Those is, you don't have to worry, because you can implement the same in any programming language. You can implement the same in Python. You can implement the same in R program also. You can implement on a MapReduce basic level. That is possible, and also this is not being used in much of the production like scenarios. We will be using Hive only. Hive is nothing but a SQL like queries. So, then why are we seeing the MapReduce program? If we are not using it, then why do we need to see the MapReduce program first of all? Why we are seeing it? Because this will show us how the thing is programmatically done inside the like in very granular level. That is the reason we are seeing this. Okay, we don't have to implement this. We don't have to write the codes for all these examples and all. No. But
so in the current world, MapReduce is replaced by what? Hive or the Spark?
In real world, MapReduce is replaced by Hive initially, and then now MapReduce is replaced by Spark. See here, one more thing what we need to understand is, even if you write Hive queries internally, it will create MapReduce for you. MapReduce for you. Okay, so still you are using MapReduce. Even if you are using Hive, you are using MapReduce only. So that is fine. But if in case of you are using Spark, then you are not at all using MapReduce. It is altogether a different framework. Currently, MapReduce is replaced by Spark only.
What is Elastic MapReduce, EMR?
Elastic MapReduce is nothing. The same MapReduce is getting run on Amazon server. That is Elastic MapReduce.
Okay.
That is just running in cloud only.
So are you saying that this Hive is not a programming language, but it internally goes and reads the programming language, which is MapReduce?
Correct. Hive, see why for Hive is created by Facebook. Why they created Hive is not many of the people who knows data, they don't know Java. So that is why Facebook comes up with the idea. Okay, you write SQL queries. In backend, I will convert it into MapReduce program for you. That's what it does. So comparatively, MapReduce is more powerful than Hive, but the time taking to write a program in MapReduce is more. So that is why people often go into Hive. 80 to 90% of the projects use Hive. Without Hive, there is no project. 80 to 90% uses Hive.
So is it a GUI kind of stuff or?
No, it is SQL queries, entirely SQL queries.
Okay.
Hive is entirely SQL queries. Just all SQL queries will come. But anyway, it is not exactly RDBMS, but it uses SQL queries. SQL. They call it as SQL. It's simple only. Okay, so that's how we are using. So that is why we are going to see this. And if you understand the logistics, how these things works, it will be very useful. Whatever the distributed language, whatever the things you are going to learn, because Spark also somehow like connects with these things. Like you can understand easily. This happens in like hard disk, that Spark happens in memory. That's all the differences. Not much different. Okay. So this is a basic class which we have implemented. What we are going to do is, I have one file. This example is very simple example only. I have an input file. Let's say hello.txt. All I want to do is, I wanted to count how many words are there in the file. So for any given file, all I need to do is, I need to count how many words are there in the file. So for this algorithm, we need to just write an algorithm first. Okay. So my task is to count how many words are there in the file. It's just a word count program, nothing else. But from the word count program, we can develop anything. But whatever we are going to write is just a word count program. All we need to do is, we read one file, just count number of words. That's it. For that, what I have to do, algorithm, I'll just read the file first. This is just algorithm only. I'm just writing what are the steps we need to follow in order to find how many number of words are there in the file. We need to read the file. After that, what we need to do is, we need to extract each line. And then we need to split the words. We need to split each words, and then we have to separate it. After that, what I am going to do is, I will give each words, I'll give one number. Okay, each words I'll give one number. I'll just give one. Okay, each words I'll give. Let's say I have an input called hello. This is Aru. This is my input line. What I will do is, I'll give number as 1 for each word and make it as key value pair. So what I will do is, in map program, what I'm going to do is, I'm going to give number to each things. Hello, comma 1. I'll just make the key value pair like this. This comma 1. And then is comma 1. 1. Okay, let's say I have 2 times arrow. Then again, what I have to do is, I have to give. This is my map. This is what I'm going to write in map program. Mapper level, this is what I will implement. So after this, what I will do is, I have to write a reduce program. 5 is my reducer. All my reducer has to do is, group by key and then sum of values. Okay. So here, what is my key and value? Key is words, key comma value. Correct. Group by key and sum of values. So this will give me hello comma 1. So everything is one time only. This comma 1, this comma 1, arrow comma 2. So this will my reducer result. Fine. So this is what the algorithm will look like. So I'll just repeat it one time. I'll just read the file and then extract each line and then split each words. After that, I will give one number, like 1 is a constant. I'm just giving just for counting. I'll give everything 1, 1, 1. After that, in the reducer program, what I will do is, I'll group by key. This is a key, this is my value, and then I'll group by key and then sum the values. So if hello is there one time, then I'll do all the values, I will sum it. Same thing if I do arrow is 2 times, so this is getting sum, that is 2 times. This fine, everybody? Anandji, Anbuji, and Bala, Guru, Swamiji.
Yes.
Bangar Samiji, Shivaramji.
Okay.
One question.
Yeah.
I understand your concept completely.
Okay.
Just other way to think.
Hmm.
Your intention is to just to get the number of words on the count, right? How many times it occurs.
Correct.
Instead of giving, I may be wrong. Just want to understand. Instead of giving hello one, this one, I understand why you are giving one, because finally when you group by the word, if you count all the ones, that will give you number of words per word, right?
Yeah, correct.
We have another aggregation statement called count of words, right? Yeah. If in case I have the hello, this is aru, right? If I group by that word, and instead of sum, if I put a count, anyway, that is also going to give me the number of count, right? Why should I follow this process?
Exactly, you're right. So which language you will use it? You will write it in a SQL, right?
Mm-hmm.
So in SQL, what is a physical plan that will be generated in behind the hoods? If we write SQL program, behind the scene, there will be one SQL that is like physical plan, logical plan will getting generated, right?
Yes.
So that we are writing that program, like that level of program in Java. So this is, you are saying this is, we can just do the count, right?
Count of that word, if you give, that is going to give you, see, if I put, for example,
you are saying count of the words. Okay.
Yeah.
In here itself, you want to do count of words.
If I assign hello into a word, this into a word, right? If I'm assigning a word and moving word by word into that variable, if I make a count of that variable in a loop, that is going to count the value, right?
Correct. Yeah, that will count the value. That should be fine only. But how we will implement this in MapReduce? Because in MapReduce we have to do the two level of processing. So where you can implement the count, here or here? You are absolutely right only. There is no wrong. Count we can do, and we can just add everything into an array, and we can do that. But in MapReduce way of implementing, we need to think a way to implement this. That is why we are using this one. That is also fine. You can try that out. You can just change the program after this and try it. That's possible.
Okay.
But how do we implement it in a MapReduce way? That we have to think.
Okay. Yeah.
Because this is two-level programs. This is map. This is reduce. Okay, but yeah, that's fine. That should be fine only. It will work. Counter. There are a lot of ways we can implement this. So anyone else? Everybody understood what is the like algorithm here we used?
This is just an algorithm, right?
Yeah, this is algorithm.
It's not way of writing a program.
Okay, fine. So same thing we have implemented. Whatever we have seen here, we are implemented in this program. Okay. So whatever program we write, whatever MapReduce program in Java or Python or R program we write, we require three things. One is map. We have to implement map. What is a map? We need to write a map class. This is a class, map class, and then one more thing called reducer class. Both is important. In there, we will be writing what is a map. What is a map function? Here, map function is nothing but reading and then give each number as one. This is a map function. This is what we will write in the map function. And then in reduce, we will write just this one. Okay. And then one more thing will be there, which is a main function. In that, we will write everything about driver classes. What is map? Entire job configuration will be put into the driver class, which is a main class. Okay. So first, we will see the map class. Okay. Three things we'll have. One is map, one is reduce, another one is driver. First, we'll see the map class. So in map class, this is the predefined method which we have to extend from the MapReduce class itself. Extends MapReduce base and implement mapper long writable text and text int writable. So what is this one? So this one, so MapReduce implements mapper long writable in text and then int and text writable. So here what we are specifying is first two things. These two things specifies input key, comma, input value. This first two things specify input key, input value. After that, what specifies map reduce output. Output key, output value. Map like mappers input and mappers input key, input value. Mappers output key, output value. This is what we are specifying. Those data types. Okay. So long writable is nothing but long. Text is string, and here also text we are having like input. We are using key and value as a long writable, and text will be our input. Output of mapper is text and int. So how do we define output of mapper as text and int? So for that, first of all, we need to understand what is the input to the map. Input to the map is it's just a file, right? We are just reading a file. It is just hello.txt, which is there in somewhere in the SGFS path. We are just reading the file.
One question. The map reduce base implements mapper. What it means? That means base class. Which is the base class and which is the derived class?
This is a base class.
Okay. Okay. Implements mapper is whatever we are defining.
We are using.
So the properties of map produce whatever the functions are over there. The class will be applicable over here.
Correct. Exactly. Whatever the functions are there, it will be applicable over here.
Okay.
Yeah. So for the mapper input is hello.txt. So if we read it, mapper has to read those file first of all. So for that, what it will do is it will use its offset value as a key first. Offset value as key. So that is why we gave long writable. We don't specify it here because it happens automatically. That is why we did not specify it here. Offset value is a key, so that's why we gave long writable. Okay, and then we gave us a text. Text is the entire text of this line, like hello this is Aru. That will be read as a text, whole text itself. That will come into the value. That is why we gave the text as a entire line is a value. That is why we gave it as text. This is mapper's input. Okay, mapper's input key is this one, input value is this one. So we are reading as a file, and the file has an offset value. Each file starts with the offset value. Each line has an offset value where it is stored and all. That is what we are using it as a key in our first level. And then that's the entire line is a value. So once we get the data into our map program, all we have to worry about is a value only. We don't have to do anything with a key. All we need to do is split this one and then give one number to everything, and then we have to make it looks like this. Correct? So after the map reduce program, once we read the file, all we have to worry about is a value. Value means this line. Whatever data comes, that's what we need to worry. So what we are going to write a logic about this is we have to change this something like this. That's what this should be. Our map output should look like. Our maps output should look like this, but the input is like this. And also, if you know about objects and serialization and deserialization in Java, and you might not have seen text anywhere. Correct? This text and long writable you might not have seen. This is not a Java's serialization method. This is not serialization for Java. Correct? Text you don't know. In Java, what we use is a string. String is object. It's a data type. Correct? We did not use anything called text. Text is particularly used in Hadoop only. These all the data types and serialization that is specifically available only for Hadoop. Okay, Hadoop has its own serialization. Okay, so that's what we need to convert this text into string first. Once we receive the text, we need to convert into Java first. Java object as a string, and then we have to separate the text. We have to like play with the text and change the text, and whatever program we need to write, we will write it. So that's what we are doing it. We are receiving a text here. This is our exact map function. Okay. So int writable is a key, text is a value. This is my input. Input value comes. Once input value comes, after that what we are doing is we are converting into a string so that we can play with the string easily. We can split it, or we can do the space split, whatever we can do, we can do. That's why we are doing it as a, we are converting it as a string first. We are changing the this text into string first. That is the first line of code we have wrote here. Fine. I'll just repeat it once again. We have special serialization and deserialization method for Hadoop itself. Hadoop has its own serialization methods. So why it has serialization, we'll come back later. Because it is transferring across the network and all, we need own serialization. That is why Hadoop went to own serialization. It did not use Java's existing serialization methods. It uses its own serialization for that purpose only. Okay, but once you write a program in Java, you have to convert that into Java, do the language what Java can understand and what Java can play with. That is why we are converting this text into string as soon as we receive the file, text. Okay, till now everybody is on same page. It is not a big deal, but just if you are listening the first time, you might need some time to grasp. That's why. Anandji and Anbuji and Balagusamiji and Selumji. We are just seeing the map program. Yeah. We are just seeing the map function, part implementation, how it is done. Okay. So once we convert into the string, after that what we are going to do is we are just tokenizing it. Tokenizer is nothing but it will split the entire line by spaces. Okay, not clear much. Okay, which part you are not clear, Ji? Entire part.
Yes, entire.
Okay, so did you understand this? Like read file, extract each line, give us this one.
Yes.
Okay.
This Vinod. So you already explained what is serialization. If yes, then I will check the video because I joined a little late. If not, can you explain it?
Serialization and deserialization, yeah, we will see it in after that sometime. Because serialization and deserialization, if we start it will take a lot of time. We will see it in some time. To put it in a simple way, serialization and deserialization, if you send some data across the network, you have to serialize it because it is going to transform as a bytes into the bits and bytes across the network. So that time you will have to serialize the data. But once you are going to process the data, at that time you have to deserialize it and then use it. It is like sending it as a package. Once you send the package, it will be sent across the network using serialization methods.
Okay. I got that explanation. I understood this one when you explain it, but exactly what is serialization? Okay, if I'm sending 010101, if I want to serialize it, what does it mean?
In programmatically, all you have to do is you have to go and dig deeper in here, and then you have to see like there is a method you have to use, then it will get serialized. That's what we will do.
So is it a number assigned to each packets, or is it a number assigned to each word?
Details, yes. There are a lot of things happen. Number will assign, and then it will, each packet will move here and there, and first and last byte will be checked. Those things will happen.
Maybe I'm not asking the question correctly. Let me explain you this. So if in case you are reading something in C or in COBOL, right?
Okay.
A flat file. When I say sequential reader, what is sequential reader? How you want to read the file, you will mention it in the COBOL, right? Sequential. When you say sequence, which means it will start with the first line, it will keep incrementing incrementing the pointer, it will go line by line, one by one in the same order, the file it appears. That is what the sequential read means, right? Random read is just pick any row based on what is the number, what is the pointer it points to. So in the same way, if you can explain what is serialization, that will help us to understand it.
Okay, serialization is...
Now, my understanding of a serialization is to write it to a file.
Okay.
So that is serialization, and then when you read it from the file, it is a deserialization. Is that right?
Write into serialization. Okay. So, sorry, come again. What is serialization, you mean?
Serialization is like writing it to a file system, and when you read it from the file system, it is deserialization.
No, that is not serialization. Serialization is nothing but currently what you have to do is, if something, you are reading something from the file, you are reading something, then it has to go across the network, right? Like it has to go across the network here. Like you have a data in some file system, any file system. You are reading it from here, and then it will go into your, wherever you are doing a processing, there the processing is happening. Here, let's say here the processing is happening. Processing is happening here. Once you read the data, it has to go into the network. There are some wires, switches, everywhere it has to go there. So that part, while reading itself, it will get serialized. From here, it will get serialized. Then data will flow across the network. Once you read, even if something gets attacked, you get the data from like in between, you will not able to understand the entire data. But once you are able to deserialize it here, then only you will able to understand and make a meaning out of it. That is called serialization and deserialization.
Oh, okay. Yeah, it's indirectly like encrypting and decrypting.
It is not exactly encrypting, decrypting, but it is similar to that. It is not created for encrypting, decrypting purpose. It is creating for efficiently using the network.
Okay,
so
got
it
it.
is, okay. Are you saying that it is meant for where to store back? So from where it is retrieved and where it has to go back again? Something.
That is, for that also it is used. And one more purpose why serialization is required is, in order because if you have an object, something very big, you might not able to transport it into the physical layer of your program. That is why you need serialization, so that it will be like send it as a packet, and then it will be at the receiving end, you will be able to receive it and process it. Because in network, some packets may go first or last, something like that. So that is why we have a serialization and deserialization in every programming language.
Yeah, got it. Yeah, thank you.
So that is the serialization. Java has its own serialization. So Hadoop also has its own serialization methods. So that is the point here. Okay, and so this is the logic, and this is what we are implementing. Like this is a map function which we are currently implementing, and we gave like this is so this is input and input key and input value for the mapper. This is output key, output value for the mapper. So we are just implementing the mapper first, and input key, input value we defined, output key, output value we have defined. And inside, once we receive the data, we convert it as a string. After that, we are splitting it into the splitting it using the space. Okay, and then tokenizer we are making as a tokenizer. String tokenizer is a Java method. What this will do is, this will split the entire line into number of tokens, and then each token will be assigned to one location of the array. That's what we will have. And after that, we are just iterating the same tokens, iterating each words, whichever we split in the previous line. And then what we are doing is, we are giving one. One means nothing but it is just a single one we are giving, and then we are writing into the output of map. If you look at here, this is what we are doing in this line. We are just a word, each word will come here, And with each word we are writing one. One is nothing but we created one final static variable which is just one number. That is the output of our mapper. That's what we wrote in this particular map block. Okay.
The word ONE stands for the used to count later. Number one. Okay.
The word now one is nothing but it's just one, because we like mention it here, right? This is the output for the mapper function. So here we have specified this is the input key value pair. This is the output of maps key value pair. So why did we give text and int? Because this is how our mapper's output will look like. This is the text, this is the int. So that is why we give int writable text. Okay.
Why it is in the map? It's a long writable command text, and why it's a text? And because this is the value, and this is the this is the value, and this is the variable, right?
This is a value.
Right. That's the variable, right? That's the variable, and that's the value, and that's the text.
This one, right?
Yeah.
Yeah, correct. This is a data type. You can simply put this is a data type. This is a variable. Data will assigned here while running the program. Data will get assigned here.
Okay. Yeah, on the top, on the first line, I'm asking the long write variable comma text, right? So that is the first is the long writable is aru.
So okay, here we are reading the text. This is the input to the mapper itself. Okay, what is the input to the mapper? That is a hello.text, right?
Right.
So hello.text, we are reading it by the offset. So there the offset value is long writable. Here we are reading hello.text, we are reading in mapper, right? So for that the offset value is long writable, and then the entire data is entire line, entire data and entire data of the file is text. This is the input to the map, right?
Okay. Yeah.
Got it, G?
Yeah, the text is type. Yeah,
correct. Text is entire data in the file.
Yeah. Okay. The long is type then. The long is type and the text is the value.
The text is also type.
Okay.
Here we don't mention any variable. Everything is a type only. This is a long writable is a type. The text is also type. Here what we are doing is we are just telling the program. So okay, just listen. This is what I am going to use in my program. Just be aware. That's what we are telling here. Implement mapper means we are going to implement this kind of things in my program. So be prepared. That's what we are telling in this program. In this line, exact line. This implement mapper means that whatever the data for that will get implemented here from the library of Hadoop. We imported the Hadoop library here. If you see, from there it will get implemented. So is it possible? Can we write text here also? Yes, absolutely, it is possible. But for that we need to have a different kind of input data. In that time we need to write text over there also. Those things can be changed according to our program needs. It is not fixed. For this particular program, we are using this. But for next, whatever, if you want to change the program, if you want to write for some other program, then this will change for sure. Okay, so once we get the output of the map function, this will be input to our reduce. So whatever your output of the mapper will be input to mapper's output will be fed into reducer's input. Okay, so in that case our reducer's input key value pair will look like this. This is a reducer key value pair. It will look like this. So this is my reducer key value pair. Because mapper's output is, this is mapper's output, right? This is my mapper's output. This is my mapper's output. And what will be my reducer's output? So, okay, first of all, this is mapper's output. This will be fed into reducer's input. Correct? So, here, this is what? This is text, comma, int, right? Correct? Is this fine? This is text, comma, int writable. So, that is what I will mention in my reducer's input key value pair. Okay? This is my input key value pair. That's what I will mention. Here I will mention outputs key value pair, output of reducer. Output of reducer is a final result. What it will have? It will also have something like it. Hello, comma 5. It just have the final result. Test, comma 8. Whatever the total number that will have. Still that is also text and int. Correct. So that's then I will again use text, comma int writable over here also. So I will define the input key value pair, output key value pair for my reducer also in this line. Okay. And then inside my reducer, all I have to do is I just have to submit based on the key values. So here I will get the iterator based on the key. So MapReduce itself, what it will do is it will send the data based on the key itself. So hello, then it will have something like this 1, 1, 1, 1 in value. So all I have to write in my reduce program is just to add the everything. While the values has next entire value, just for each key you just have sum it up. You just have sum and then write it into the output collector. This you just write a key and then a sum. Then it will get right into the SDFS output. That is my final result. I hope everybody is lost. Good. So somehow you are trying to you are able to understand what is the overall picture is going on. Yeah, I
Can you repeat
completely
the
understand.
mapping and the reducing part again?
Yeah, yeah. Sorry, mapping and reducing, right?
Yeah.
Yeah, yeah. Sure. So you are talking about the input and output.
I'm just trying to understand how this is done in Java.
Yeah. What is done? Can you repeat the question, please? Sorry.
No, I'm trying to understand what map exactly does and the reducer exactly does.
Okay. So in this, like you can at each program, at each given problem statement, you have to write your own logic for mapper and reducer. In our logic, what we are going to do is we are going to write this as a mapper and this as a reducer. Okay. So mapper, what mapper does is it just gets the entire, it just reads the file and extract each line and then split it into words and then give one to each line, each word. That's what mapper does in this program implementation. After that, what happens is in reducer part, I'll just use the key to sum the values, key comma sum the values, and then I will write it into the output. This is what happens in this particular program. That's what mapper and reducer does in this program.
One question.
Yeah.
I understand what mapper is doing, what reducer is doing. These two are two different tasks. Okay, let me ask the question this way. So we will have more than one node, right? The file that you have taken here is very having only 5 words. So it will stay in any one node. Let's assume you are passing a 1 TB file and that is storing across the node, right? and when you execute the mapper will get executed in all the nodes.
Correct.
Right, and it will assign the key and the value in all the nodes. Then your reducer will come into picture.
Correct.
Whether your reducer will run in all the nodes or that will execute it in a specific node by collecting all the value.
Exactly. Reducer will run in specific node by collecting all the values. The output
Then,
of the mapper will go into, that's why we have shuffling process. It will go into particular reducer and then it will run.
okay, so which node it has to go, everything is predefined internally. We don't need to worry about that.
It is specified internally based on the availability of the node. Correct. It is specified internally.
Okay, yeah.
Okay. So in our particular example, it is just it's a word count. Okay, if you have multiple keys and values in different scenarios, that time you might have multiple reducers. You can increase the number of reducers also, but anyway, that's a special case. That time also multiple reducers will happen. So in that time, what will happen is, let's say you have 1,000 keys. It's just a scenario for reducers. You have 1,000 keys, just for example, and 500 keys will go into one reducer. Keys will go in. You are defining two reducers. How many reducers defining is in your control only. Reducers you have two. 500 keys will go into one reducer. Another 500 will go into another one. So like that it will happen. So in that case, the output of the mapper for a particular keys will go into one node. Output of the mapper, same our mapper has two output. Then one will go into one node, one reducer. Another will go into another reducer, which is running in altogether different node. Got it?
Right.
So then the code.
Go ahead.
Yeah, then the code level, do we have to write two reducers?
Yeah, we have to specify two reducers here. We have to mention, we have to run two reducers. That then it will run.
Okay, but the user wanted to see one output, right? For example, if you have Aru in two places, right, and think that the first Aru is going to the first reducer, another Aru is going to the second reducer, but what the user wanted to see is there is two Aru available.
Exactly, that is exactly right. In that is what partitioner will make sure. Will make sure all the same keys will go into one reducer. That is the partitioner's exact job. It will make sure all the same keys will go into only one reducer. It is not going to some other reducer.
Okay.
So that is partitioner's job.
So even based on this file size, we can create multiple reducers, or how it will be? In what scenario more than one reducer will be created?
If you have only one output, then it is not it is not advisable to create multiple reducers, because in that time what happens is your final result will be only one. So in that case you will not be able to create multiple reducers. And if something like a word count and all, you can create multiple reducers based on the number of size of your data that you can create.
So you mean to say that if I am using a same input for multiple outputs, then at that time I can go for multiple reducers.
Correct, exactly. You can go for multiple.
So one is if I am going for a word count, another one is I am going for a line count. Then in that case, is it good to use multiple reducer, or still we can do it with the same reducer?
If you are going to, you needed two results, right? You are going to perform two results, two different functions here, right? So in that case, you can go for same reducer or multiple reducer. Both are fine. But it is advisable to go for a single reducer, because you can apply this same logic in one data set itself. If your data set is too large, then only you go for two reducers. It is based on data size. See, and let's put it this way. So I have this one, hello. I have one file which is having hello 1 crore times. Okay, I wanted to count the number of hellos in this files. Okay, only one task. I wanted to find the count of hello in the file. So in this case, if I write one reducer, I have only one key here, correct? I have one key only. If I write 2 reducers here, then what will happen? Any idea?
Same data will be
Duplicate.
spread across. Duplicated, right?
No, it will not go into at all, because the partition will send it to the one place.
Exactly. So what will happen is entire first reducer will take 100% load. Entire data will be go into first reducer. Second reducer will have 0 records. It's just idle only. So this is a wrong configuration. You shouldn't do this. If you have 2 hello comma, you have one more value also. You have hello comma aru. You have something like that. This is one core time. Now what you want to do is you want to find this hello and aru. In this time, what happens is this time your load might get shared in here. Then here 50-50 will happen. Correct. It's based on purely based on how much load you are giving, how much number of keys.
Okay, so multiple keys means then it will split across.
Correct.
So one node will search for, one mapper will search for one key, and another one will search for another key. Correct. And together that will be reduced in the reducer.
Yeah, exactly. That's what happens, because you have only one key means if you need the result, it cannot reducer cannot run in multiple nodes because you need only one result. So partitioner will make sure the entire keys will go into only one reducer to make sure the result is intact. Else the result is wrong, right? Here 50, here 50 means you will not get the count. You cannot go and finally and add it something. No, that will not work. So it's based on the keys, number of keys. Understood?
Yeah.
Okay. So this is what happens in MapReduce most of the time. That's how we need to make sure the data, based on the data, we need to look at it. Sometimes that happens, like 0 file record will get created a lot of time due to this reason, because it doesn't have anything, any data to process. So in that case, what we have to do is, if you want to do one more level of efficiency, you have to write custom partitioner. This is advanced level partitioner to make sure you are sending the keys to the particular reducers that you can like implement. This is a one more level of advanced level. You can do it. So in this time, what you are doing is you are taking control of the data. That is possible. Custom partitioner you can write and you can do it. That is also simple only. All you have to write is here you need to write partitioner and then just take the reducers and all. It's simple. But that's what happens. Okay. So here the output collector will write the data into the final result, that is SGFS. So that is the entire thing. This is how this thing will work. This is map and reduce class. So we will see the driver class now. Driver class is nothing but we will mention the job configuration here. So job conf word counter class, this is my class. So that's what I mentioned it here. Conf, I'll create the conf and then I will create the job name. Why job name is required means a lot of people will run jobs. So we need to make sure what is our job. So that's why we write a job name here. And then we need to mention 2 important things here. What is my output key class, output value class? Finally, what is my output and output key and output value? This is my entire output. What is the reducer's result is this. Reducer's result is this, correct? So output key is text. So text class I'm giving. Output value is int writable. So 1. It is again going to be the integer. That's why I'm giving int writable. And then after that I'm setting what is a mapper class, what is a reducer class. And also one more thing we said, what is called combiner class. Okay. So what is combiner? Combiner is very interesting concept. So we have map and reduce. Okay, this is map and this reduce. Okay, so we know that map will happen in each block. Now we are going to see what is combiner. So map will happen in each block. Let's say these are the blocks. Map will happen here and then here and then here. And then output of the map will fed into one node for reducing. Same keys will go into one reducer that will taken by partitioner, and that will happen in one node. That is a reducing part. If such case, like something like a word count program, I have something like this: hello, comma 1, hello, comma 1, aru, comma 1, comma 1. This is my mapper's output. Okay, this block's mapper output. This has to get transferred into the network. Across the network, it has to get transferred. This is having 4 lines, correct? But my final line, what I want is, anyway, I am going to group it by hello, comma, whatever the number, every 5 or something will come. Instead of doing this, I can do one more level of processing here and make it as something like this: hello, comma 2, aru, comma 2, and then I can send it to the send it across the network. This saves my network bandwidth. Correct? Correct? That is what we are calling it as combiner.
So we're doing a mapper work here itself.
No, we are doing a reducer work in mapper itself. That is called combiner.
Yeah, reducer work.
Combiner is nothing but mini reducer. So one time reducer will run here. After that, it will get transferred across a network. If you look at it as a larger data, this will impact a lot. But smaller data, no, it's not impact. But larger data, yes, it impacts. So that is what we call as combiner.
So the combiner, no, it is not a reducer, right? It is a combiner.
It is a
once the mapper is done,
after each data chunk, it runs and like sum it up.
No, after the mapper runs, the combiner will do the
correct. Combiner
summing
will
up.
run in the data chunk only. In the 64 MB block, whatever the result of mapper, one time the combiner will run. We can write our own combiner, or we can use reducer as a combiner itself. Anyway.
Reducer as a combiner. Okay.
We are using the same here, right? Hello, comma 2 only. That's what we are doing here also. We are adding it up, summing it up. Same thing we can do there, so that it reduces the work of reducer. Like network congestion.
Okay.
So this combiner will be on the mapper.
Yeah, it will be on the mapper. If you see here, we are giving the combiner class as the same as a reducer class only. So that is what we are now seen. It is just a reducer class. It is a mini reducer.
It is also kind of a daemon process.
It is it is. We are just maintaining it, right? It is same like mapper, combiner, reducer.
Okay.
If you want to write a combiner separate class, you can write it. That is also possible. But here, we can use the reducer class. Most of the implementation will use the reducer as a combiner.
So then what the reducer does in that case?
Reducer does the same, right? After
but again, the data is fed into the reducer, right? So the reducer again reprocess it?
Exactly. So this is a one single block, this combiner happens. Multiple blocks will come, right? So entire whole picture, here also it will come data. So that entire data will be finally resulted into one block. That is the reducer's part. This will happen in each mapper's block. Each mapper, one time it will run. This block will have something like hello 5 times, hello 5 times. Correct. So that will entire picture will be get by reducer. Hello, comma 6 is there, and this is the combiner's result. So altogether, whole output you will get it here. Hello, comma 2 plus 3 is 5, and then aru, comma 6 plus 2 is 8. That is total reducers.
Output of the reducer.
Output, because it is having an overall picture of the entire whole data. Combiner's part is just one data chunk.
So the combiner class and everything, right? So we have to write inside that method, right?
Yeah, we are writing it here.
You have to write inside the method, but so the ideally, so then when we are writing a method, then what is the purpose of the class? Ideally, what it will intimate to the machine. You
write a class, something called reduce, and how does it know where it should run? That is the framework which is set by like Hadoop. Like we are writing all these things, but we just mentioning it, use it as a combiner class. Then where it should run, after the reading of this one, it should run. So how does it manage, how does it manipulate it? That is what framework does.
Okay, where and all it is run, and where
what is
at which point it has to run. Okay.
Correct, exactly. What is the structure? Okay. What is the first thing? What is the second thing? Where, what time like partitioner should get invoked? Something like that. Those things are handled by framework.
Okay.
Okay, and then we are specifying the reducer class, and then we are giving input format and output format of the data. Okay, text here we are just using plain text only. And after that, we are setting input paths and output paths. Why we are giving argument 0, argument 2 is we are going to provide the path while running the program. That is why we are giving it as arg0, arg1. While running it, I'll show you where we are giving the input path and output path. So after that, what we are giving is we are giving job client and then run job. This means this will start the job. Our job, it will start. Okay. So,
or the text.
Is it like a first in the what is that class? The derived class, right? Sorry, static class. We'll define it as static, right? That is the main class.
Exactly.
Likewise, okay. So the last one you talked about, run job. So always we have to mention in the static class.
Correct. Always we need to mention this run job to start a job.
Okay, inside. It should be inside the static class, or
it should be inside the main class.
Okay. Okay.
So what
in
is
Java it doesn't require, right?
No. Java, what happens is it starts from here, and if job client or run job, it is required to run the job. That's what I understand.
In Java itself?
No. Whatever I understand from the Hadoop is job client or run job will start the job and then it will keep it going. I think it is required.
Okay. Here, but in general Java programming, as soon as you mention a static class, then that will be the first class. That will be triggered automatically.
Fine. That is fine. I understood. The static means it will get created only one time, then it will run. Yeah, that is fine. But here, the job client or run job is fine. Here, we are not creating an object or running it, right? This is just, we are starting the program. We are not creating an object for it or running. If you think that's
okay.
Static will get created only once.
Okay.
So, whenever Java program starts, what happens is it will look for the main program, and from there control goes there. From there it will start running the program. So it will go here, it will start here, then it will go into a mapper reducer. Everything will get converted into byte or byte, whatever things that will happen. Okay, fine. So I hope you get the picture. I'm not I will not say like everybody should get the syntax. Syntax is not at all required. This syntax is very, you don't have to worry about the syntax and all. But anyway, I know everybody is already very well experienced and is not required. All the thing is we need to understand how this thing works in behind the hood, how we can implement. Because even if you write a SQL code, if you write a HQL code which is very simple, behind the hoods this will happen. So if you know this, you will be able to understand and optimize those things. Because sometimes what happens is one mapper failed in Hive program. Whatever, let's say you are writing a program, you have a table. Select star from table. This is the exact same thing we will do in our Hive program. And then it fails. It says map failed. Mapper failed. So in that case, we should know what is a mapper, what is running behind, how the mapper is running, how it's like which, if it is failed, where should we go and check, what could be the reason. Those things we need to know. So for that reason only we are seeing this. Okay, it is not necessary that we need to know Java. It is good to have, but because somebody uses or something, but it's not necessary. All we need to do is understand those things and all. Fine. So let's run this program and then check whether this program actually works or not. For that, I'm going into my Cloudera. So I'm just opening my Eclipse. This is the IDE which we use for such developments. So anybody have experience with IDE programming, implementing IDE in programming? Scala, anything, any programming language. Anybody using IDE? Balagur Swamiji, Anandji, or Anbuji, Ganeshji, and Selumji. Okay. So all I will do is I will do right click, new, and then I will click Java project. I'll click WC, and then I will click next, and then I will click finish. So it created one Java project for me, which is WC. I gave it as WC. After that, what I have to give is I'm going to right click here. Sorry, it just hung. Right click, new, class. Again give word count.java, and then I will finish. So this is my word count program. All I will do is I'll just copy and paste the program whatever I have. Copy and then control A, control E, control X. So it is showing a lot of errors, which is Hadoop errors. So we need to import the Hadoop libraries here to avoid this errors. So for that, what I'm doing is, okay, still everybody is able to understand. I just created one Java project, and then I added a copy pasted the project from there to here. Okay, and also we have the same whatever thing I'm doing, it is there in the screenshot by screenshot in our assignment. Each thing is there as a screenshot how to run the program. Okay, if in case if you need reference, I added it again. It is showing.
The Eclipse is a freeware.
Anything?
Eclipse is a freeware.
Freeware? Eclipse is a freeware. Correct. It's a,
okay.
It's an open source. It's freeware more than open source. You can. It is there already inside your VM. If you want to download also, you can download and install in your Windows also. I have it here also. I have multiple versions of Eclipse. It's a freeware. Okay, so I just need to add the Hadoop libraries here. So all I'm doing is right click, properties, and then Java build path, add external jar, and then I'm adding it all the Java files which is required here. So add context. The name of the class should be same as the name of this file. That's why it says. Now the error is gone. The program is fine. It looks fine. Okay. So all I did is, as per this document also, what I did is I created one program Java project and then one class, and then I copy pasted the file. And then I added the Hadoop dependencies.
How do you get the jar files?
Jar files you can download from the Cloudera VM itself. Cloudera VM, they have the repository. From there you can download the jars.
Now into Eclipse, how do you import it?
Okay, Eclipse, right? Right click, go to the project, right click, properties, and then Java build path.
Okay.
And then add external jar, control A, okay.
Okay.
Right click, properties. Okay, so once
how do you download from the external, like I need to go to the website, right?
You need to go to repository of Cloudera.
Repository of Cloudera. From there I download it to my local machine.
Yeah, no, for this exercise, it is already available in your share folder. You can just copy it in your folder and run it. Hadoop jars are available. In the assignment, Java MapReduce, it is available inside. You can copy and paste. You copy and paste it into your VM, and then from there you can add it. I have it in my home folder, Hadoop jars.
So it's okay. So it's already there in the.
It is already there in that folder. Assignment folder, it is there. Inside MapReduce, there Hadoop jar, and how to run the steps is there, and Java program is also there, and one more case study is also there, just for understanding how to run this program.
Okay.
Okay. So once we are done with the like program and no errors are there, we need to run the program. So how do we run the program? It is all same. Whatever we are going to run here, same way we'll run in production also. So I'll just export the project, right click, export, jar file, next, and then I'll give a name to that, WC jar, and then I'll create a jar. It created a jar file in my desktop, wc.jar. It is an executable file. With this, I can run the program. So I'm just opening CD desktop. I'm going. So here I have a wc.jar is there. So how do we run the program in Hadoop is Hadoop jar. Like same way, how do you Hadoop FS? Same way we have Hadoop jar and then wc.jar. After that, we need to provide the class name, whatever the class name we are using here. Here we are using word count. So we need to give the particular class name here, and then we have to give input path and then output path. Output where it's stored. This is how we need to give. Before that, we will find out what input we can give. So for that, Hadoop fs ls plus so here I will use this input.txt. Hadoop fs cat it is just having some kind of data. Okay, input.txt is not some data. Anyway, that will also work, but we'll not go there. Hello.txt. Okay, so just for dummy data I'm having. So this will give an input. I will just give the input text and then output path user Cloudera output of MR. Okay, output is a folder, it will get created. So this is my input, this is my output. So if you can see number of input path process running a job client is started, map is 0, reduce is 0. First map will get completed, after that reduce will get completed. Map is completed, reduce is 0% now. Reduce is also completed. Okay, the entire job is completed. Job status, count as 33. This is the job ID. That's a job ID. Fine, everything should look fine. Let's see the output. Output folder is output.mr. So there we will go and check what happened. Hadoop fs-ls. Result is there in Hadoop. If you see, result is there in the Hadoop. So I have three things. One is success, logs, and then part 0000. Hadoop fs cat. In this program, only one reducer ran. That's why we have only one output file. If we have multiple reducer, then we will have multiple files. Okay, so this is the output whatever we are getting. Hello.2, aru.2 going to no whatever the thing, it is just did the word count and that's the output.
So it's not giving the total count, right? Number of
This is the
words.
total count, right? Aru is four times here, right? If you see 1, 2, 3,
No.
4
Okay,
times Aru is there. So it's just 4 times Aru.
no,
Hello is
I
4
mean to
times.
say, okay. I mean to say hello is 2, aru is 4. So like the sum of all the words.
No. We need a sum of each words, right? It is not entire how many words, entire count. It is how many times the word comes.
Okay.
If you want to do that, that's also simple only. All we need to do is we just need to remove the key and then it will do the sum. It's all about changing the codes only. So here the code, whatever we did is, it is using the space, right? It is using space to change. If you wanted to use comma, we can change the code here. We can split it using the comma here. So you can also start implementing the same program in your machine. And then what you can do is, once you implemented, you run this. After this, you can change the tokenizer to other things, like how to use comma. If I have a separator and other than space, then how do we handle it? Like that, you can try that. If you go into job tracker,
default is the space then? The default separator is space, or are we specifying?
Default separator is not space. Here we implemented string tokenizer. That is why it is space.
Okay.
In Mapper, we implemented a Java program.
Right. So if we need a comma or something else, some other separator, then what should?
Here we need to change the code.
So we have to bring another method, or?
We need to write another code, like dot split and all. We need to handle it. Here we need to change the code to handle comma. That is also a very simple change. Once you complete this, you can change it. This just line that comma is very simple. I can change it right here. Here all we need to do is line dot split. You have to store it into the array. String of IP. From there, we need to iterate this one, and then we need to give it to the output.collect so that it will handle comma array, whatever we want to. We can change as per our needs. That is the changing of code. You can change it. So what we'll do is, just if you go into your Mozilla Firefox in your VM, it will have Davis name node, job tracker, those things will be there. Just go into the job tracker. There we can see the job running status. This is what our job is ran. So you can see the logs over here. So if your job fails, or if something happens in the between, whatever happens, we need to go here and check the logs. That's where we'll be able to check how many maps runs and everything. Those will be given here. So this is also one more important thing, how to check the logs. If the job is while running, it will generate logs. So here if you see, this is what runs. This is the time it will run, number of tasks run, number of completed, everything you can able to see here. All the configuration details, everything you can see. This is the URL.
So where you are checking is log?
I will just go here, job tracker, Hadoop job tracker. So currently it is there in completed jobs. What I will do is, I will run the same program again. I'll show you while the program is running. So once you ran the program, and if you run it again, what will happen is, it will show you error saying that the output directory already exists. You have to give a new directory each time. Okay. Let's see.
Something you said the job tracker, right? So do we have something for the task tracker?
No, task tracker we will be having inside the job tracker only. See, the program is currently running. You can see it here. We have a name node only, data node we don't have. Like, it is just a master node. If you go to the job tracker, you will know what is the task, how many tasks are running. If you see number of tasks, right? 2 tasks are running, where it is running. If you go into that, you can see. So only job tracker you will have, name node you will have. Name node you will have something like this. What is active and how much configured capacity, what is the DFS, non-DFS, everything you can maintain it here. But mostly we will not be using it because it is admin job, but just you can go and see what's there. So, Anbuji and Anandji and Bala Gursamiji, Ganeshji, and Selvanji, Shankarji, and Sevaramji. Is it somehow clear what we have?
Yeah, somehow clear, but I need to
Yeah.
talk to you on this later, like the mapper and reducer part
Okay.
on the programming side.
Yeah, that should be fine. We need to know, but you don't initially. I would say don't worry much about programming. Just to get how to run this, how these things work behind it. I would suggest you to like focus on those things initially. And we don't have classes tomorrow, but if any of you want to execute, you can like join the class by 7 a.m. tomorrow, like and run it. I'll just stay here. If you suck up anything, I'll just help you to fix things. So tomorrow we don't have any classes officially. We'll not do any class, but you can join the same bridge tomorrow at 7 a.m. And if you want to run the program, and you can run it by screen share, if there's any issues and all, we can fix it. Okay, so that will do.
And the thing is, Aruji, from next Sunday onwards, the classes are daily 1 hour, Sunday to Wednesday, or how it is?
From next Sunday, coming Sunday, right? Monday.
Yes.
Yeah, sure. We can. We'll have 4 days classes. From I hear like from only Thursday night you will not be able to attend, right?
Yes.
Correct. Yeah. So yeah, from Monday to Friday, our Monday to Thursday, ISC time we will have. If everybody can join in Sunday night, right? Is it possible? Then we can have class in Sunday nights itself.
Yeah, I am fine with that. What about others?
Yeah. If anybody is having any issues, please let us know. Or we can have 4 days per class also. Slowly we'll go so that we can discuss. Okay, Ganeshji cannot able to join. Sunday support is there. Okay. Okay, no, 2 people cannot join. Okay, then we are fine. We'll fix with our normal schedule only. And tomorrow, if anybody, tomorrow is not, there is no official class tomorrow. But if you want to join and do some exercise or just running the program or something, you can join and we can discuss. It's not official class, but simply we'll have discussion. If anybody can join.
Okay.
Ari, just in case if you want to open the bridge, we will let you know through WhatsApp group.
Yeah, sure. Just WhatsApp me. If anyone is joining, just let me know in a WhatsApp group so that I will also join in 7 o'clock and then we'll check if any issues or something is there.
Yeah, because before getting into this, I need to install first.
Yeah, sure. That's fine. Even if you want to install also, that should be fine tomorrow morning, 7 a.m. If you want to install, if you have any issues, just you can join the bridge. There is no issues. If anybody is joining, just let me know in the group itself so that I will join. Else I will not join.
Sure.
Okay.
Yeah, thanks.
Okay, fine.
Okay, thanks.
Yeah, so in this share folder, we have the Java MapReduce part. We have the jars available, and also one more case study we have. Whatever we've seen is just a word count program. That is a very basic, but that is very useful. And we can do so much more things in this MapReduce program. If you are more interested, you can process the logs and get those things. Those is fine. This is one such thing. We implemented on MapReduce for that. So you can try implement it. That's also available over there. But before that, just understand the program, see the video and see it once more time, and then you can come to that. Program jars availability, everything is available, and the step-by-step guide is also there in the Java MapReduce folder. And watch the video once again if you have any doubts. And yeah, so we'll see on next Thursday morning IST 7 a.m. your Monday night. If you are joining the bridge tomorrow morning, just ping us in WhatsApp. I'll join. Okay. So I hope today's class is useful and interesting. Thank you. Thanks everyone for joining. We'll see.
Not Thursday, Tuesday.